Hi everyone. In this video, we will be looking at the first of the many introductory topics that you will need for Cal 1. In Section 1, we will be looking at fractions. Here are the basic operations that you can perform on fractions. You can separate fractions as long as their denominator is common, just like you can regroup separate fractions that have a common denominator as one single fraction. So this property can be used in either direction. In the case of subtractions, the fraction can be split up as well, as long as each fraction has the common denominator that you started off with. Multiplying fractions implies multiplying numerators together and denominators together to form a new single fraction. Once again, this property can be used in the opposite direction to separate a common fraction into two separate ones. Finally, dividing a fraction with another fraction can be replaced by multiplying it by the reciprocal. Notice how the divided fraction b over d has been replaced by a multiplication by d over b. Finally, the product of two fractions can be regrouped as one by multiplying numerators and denominators respectively. Here's a first example where you are asked to separate the fraction 2 plus 7 over 8 into individual fractions. As we've seen, one of our properties allows us to split the sum of two numerators that have a common divisor into two fractions. Now 2 over 8 can be simplified to a quarter, whereas 7 over 8 is irreducible. In the second example, we'll simplify the fraction 21 over 45. A first observation would be to recognize that 21, the numerator, is the product of 3 times 7. And 45 is the product of 3 times 15. Once again, one of our properties allows us to split up terms whose numerators are the product of two numbers and whose denominators are the product of two numbers into two separate fractions. I've chosen to split 3 over 3 times 7 over 15 because 3 over 3 is 1, leaving 7 over 15. Of course, many of you might have already seen a simpler and more direct way of simplifying the fraction, which is to simply observe that 3 is a common multiple to both the numerator and the denominator, and these common multiples can be removed. This is quite acceptable as well as an approach. Our following example will ask you to rewrite 2/3 minus 3/7 into a single fraction. Now remember that subtractions can only be combined as long as common denominators are obtained. We don't want to change the value of either of these fractions, so in the first case, I've chosen to multiply by 7 over 7, the fraction that was originally 2/3, and by 3 over 3, the fraction that was initially 3 over 7. You do notice that by doing so, 21 becomes the common denominator to both fractions. The numerators have become 14 and 9 by using the property that multiplies numerators of distinct fractions together. Now, having a common denominator means that the numerators can be combined, maintaining the subtraction symbol between the two expressions, to obtain 5 over 21. Let us now rewrite 2/5 plus 4/15 into a single fraction. Although we could multiply the first fraction by 15 over 15 and the second by 5 over 5, similarly to what we did in our previous example, it's much easier to recognize that 15 can be the common denominator if we simply multiply the first fraction by 3 over 3. Multiplying numerators and denominators together respectively in the product of these fractions we obtain 6 over 15 and 4 over 15. Common denominators now allow us to regroup this addition of fractions into one. And although 10 over 15 is an acceptable answer, we can also recognize that 5 is a common multiplier to both numerator and denominator, which enables us to simplify the fraction. Here's a more complex situation where we have multiple operations taking place. We will try to simplify the expression 8/15 divided by 2 minus 2/5 times 3/7. Remember, priority of operations will force you to do the division and the multiplication before focusing your attention on the subtraction. Although we are dividing by 2, we can think of 2 as being 2 over 1, which is a fraction of its own. Properties that apply to the division of fractions tell us that rather than dividing by 2 over 1, we can multiply by 1 over 2. Now, numerators for each individual product of fractions are combined. The 8 from the first fraction has been rewritten as 4 times 2. 15 times 2 has a common term with the 4 over 2 in the numerator, which we cancel off. In the second fraction, 2 times 3 and 5 times 7 are then regrouped as numerators and denominators of the last fraction. 4 over 15 minus 6 over 35 is left to be simplified. 15 and 35 certainly need some adapting in order to have a common denominator. 15 is the product of 5 with 3, whereas 35 is the product of 5 with 7. At least the 5 is common already. To create a common denominator, we will simply multiply by 7 over 7, the first fraction, and by 3 over 3, the second. That way, 5 times 3 times 7 will be common to the denominators of both fractions. Multiplying numerators together, we obtain 28 over 105 and 18 over 105. A common denominator has been generated. We can then subtract numerators, leaving the common denominator as it is. And finally, recognizing that both 10 and 105 are multiples of 5, we can simplify our fraction somewhat. Always remember, properties of fractions are applicable to complex scenarios, to scenarios that involve variables, as well as rational functions, as we'll see later.